Hi, good people. My name's Titus, and today we're going to be talking about Unreal Engine's Environmental Query System, or EQS for short. EQS is a feature within the AI framework that allows you to perform tests on the environment to produce a result that you can pass into your behavior tree to make a decision. Let's see what that looks like in practice. So we got a sample project that I have here with a little drone AI. Currently it's dumb, it doesn't really do anything. I have a navigation mesh in the scene in preparation, but it's basically just a character mesh with some animations and a Niagara effect. So let's make it patrol around the area using EQS. So we'll start off, we have to create a behavior tree first, which will include a blackboard as well. So let's make the blackboard first. So we'll choose blackboard, call it bb_enemy. And then we'll create the behavior tree, call it bt_enemy. We'll open up the behavior tree, and in the right hand details panel, we'll expand that out and make sure your blackboard is populated. If it isn't, just go ahead and select it so it has something to show. Then in the top right corner, you can select blackboard, and we're going to create our first blackboard key. You can think of the blackboard like an object that contains references to values, or basically variables. For this example, we're going to create a vector, which will store our patrol location. So we'll call it patrol lock, and then we'll save, and then go ahead and hit behavior tree to head back. Let's go ahead and set up a simple tree. We'll pull off and choose a selector composite. We're going to rename this to be our trunk. We'll pull off the trunk into our first branch, which will be a composite sequence. And then we will call that our patrol branch. And the patrol branch will just do a few things. It'll run our EQS query. So we'll choose the run EQS query. The next thing it'll do is it'll move to a location. And the last thing, it'll wait. So for the wait, we can set it to maybe 2 seconds. The move to, we want to move towards the blackboard key that we created, which is the patrol location or that vector. And then the EQS, we're going to be writing data to another blackboard key, which is the same one, the patrol location. So this pretty much sets up our behavior tree. There is one last thing we need to do to be able to run it, and that's we need to open up the AI controller. I made a custom one in this case. It's BP_enemy controller. And then we need to add in a override function called onPossess. When onPossess is called, we can then basically start the behavior tree. So we'll do run behavior tree and then just select the bt_enemy that we created. And then I've already had this set up, but for your projects, make sure that your enemy pawns, if you search for pawn in the details panel, you want to make sure that AI controller class is using the custom controller that you set up, or if you're not, whatever one you're using, make sure you're running the behavior tree from that one. Okay, so now that we have that all set up, we can go back and we can create our query. So we'll right click and then select the artificial intelligence and then choose environment query. I'm going to call this EQS_patrol. And now that I have that created, I can go back to my behavior tree, and then in the EQS tasks that we created, you can expand it out, and we can select that EQS patrol that we just set up. Now let's open up the EQS, and it looks like we have a basic graph editor here. Now these things basically populate generators, and you only have a few generator types. You can generate, search for basically actors. You can do points, grid, donut, cone, circle, even do pathing. So there's a lot of different options here. For this example, we're just going to do a simple cone. And then in the cone options, we're going to change the angle. I'm going to do a 300-degree angle. And I think that's good starting off. So let's go ahead and save. And let's see what this actually looks like. So if we hit play, I'll hit tab, or sorry, apostrophe, and then 3 to load the EQS. Then I can hit tab and then kind of scroll up. And what the EQS system's doing is it's populating these little spheres, and then it's running the test, and ideally it would pick a location based on one of these tests. Now you'll notice the winner that it picks has a score of 0, and that's because we have the EQS running, and it's running a simple test, but there's no there's nothing to test against basically, so it's just going to pick the same one every time, which is not what we want. So now that we have this cone generator, we can start adding some test data. What you can do is just right click and then add a test, and then you have a few different options here. I think the first one that's pretty good is you generally want to do an overlap test, which basically are the little spheres hitting anything. So we could choose overlap, and then you click on it so it's highlighted, and then we can set the test. Like currently this is filter and score. I'm just going to do filter only for this one. And then for the shape, I'm going to use a sphere. And we're going to make some other adjustments to it, but let's save and actually see what this looks like right now. And then let's tab over. Now we have some scores and it's kind of moving very close, so there's it's picking some of the inside circle rather than the outside before. But still nothing's really happening, but you can see the spheres are green, which is important to call out. If we go back to the EQS, and for this filter option, if I uncheck that, and then if I save and go back, and then we'll play that scene again, you'll notice that some of the spheres are now blue. And basically the blue ones are areas that the drone cannot move to because it's basically detecting a collision. And you can see that the collisions are not correct, right? Some of those should be available. So when we are populating our EQS, there's a shape offset. I'm gonna pop this on the Z by 100 units, just so it's not colliding with the ground. And now we can try that again. And we can see we're getting much better test data. There's a lot more options for the drone to actually move around to. But that's a collision check. So let's do another test. So we can right click, add a secondary test, and let's actually do distance. So for the distance, I'll do a filter and score. We can do a min, max, or a range. Let's do it simple, so we'll just do minimum, which basically it'll preview this graph here. Anything in red is going to be filtered out or scored lower, basically. And anything outside of the red is going to be scored higher. So when we say minimum, it's basically like telling your drone to move further than it normally is. And then for the scoring factor, I'm going to do something a little bit lower than 1. I'll do 0.75. And now the drone should try for further locations. So if we move up here, so before it was kind of moving towards the inner circle, and now it is preferring to move to the outer edge of the circle. And you'll notice the score values are higher at the outside too. It's 0.75, and as we move closer towards the center, it gets basically close to 0. So the drone is favoring, outside positions. So we can get that sort of behavior. And that's sort of interesting. Another test that's even better is the dot product test. So we can go ahead and add test, choose dot. And dot products, if you do, or if you plan on doing anything with game development, you should probably learn dot products because they're quite helpful. There's some interesting relationships with them. So if you take the dot product result between two vectors, it'll produce typically a positive value or a negative value or 0. For this example, we can say 1, -1, and 0. If your dot product result is +1, then the two vectors are typically facing or should be facing the same direction. If it's -1, then they should be facing opposite directions. And if it's 0, then they should be facing perpendicular directions. So why is that interesting? Well, currently we can set the dot product. Let's do -1. So if I set a value of -1 and I save this, what the drone should do is it should try to move behind itself every single time. So it'll go to a location, and then the next location it should be behind it. So if we play this here, we'll go ahead and throw up the info. Let me zoom up a bit. All right, so now we're getting some blue values. Let's see, we got an issue here. What did I mess up? Filter and score. Oh, so we're filtering. We want to do score only for this one. Sorry about that. Okay, so let's tab 3. Okay, so the drone's landing. It should pick a value behind it. So now it's going behind. And now that's landed here, it's going to go back over there. And now it's landed there, it's going to go back over this way. So you can see it's basically going, back and forth. And that's because it's favoring values that are behind the drone, because the dot product is looking for values close to -1. So it's going to produce a vector that's opposite direction of its rotation. So if we go there and we set this to +1, that's going to be facing two vectors facing the same direction, which in this case would be forward. So it's basically always going to try to go in the forward direction. So if we zoom up here, so this thing's basically going to keep going forward until it can't, and then it'll turn. So it looks like it's going to follow the outside of the map. So you can see, dot products are pretty important if you're going to be doing like AI behavior, because you can influence a lot of your decision making just by the values around it. So, but for this example, I am going to set something a little more reasonable, 0.25. I think that'll be good for this. But okay, so this is one example of a query, but you can have multiple items in a query like you can in the behavior tree, and they execute left to right. So if I add like another generator for actor, and then the actor I pick is my player pawn, third person character, and then I do a search radius of say like 1000, it's going to prefer to run this because it's on the left, and if this fails, then it'll run this. So you can influence some behavior here. So you can see the drone runs straight to me, and if I go to the EQS system, you see it puts a little sphere around me, and I am the object of its desire. So if I move away and the test fails, it'll move back into the patrol, and it'll just do kind of its normal thing. But if I move close, it'll come back to me, and I will be preferred, basically. And then we can also see that if we just basically flip these around. So if I move this over here and this like this, that is now inverted. So now when I start the map, the drone is just going to patrol. I am a second thought. And honestly, I'm never going to execute because I don't think there's going to be any scenario where one of these tests fail. So it'll basically never chase me. So that is an important point to call out for some of these examples like that. But yeah, and then if we go back to the behavior tree, this is just one EQS query that we're running in the patrol branch. You can have multiple branches, you can have different queries. So the system is very scalable, it's very powerful, and you get some interesting AI behaviors from it. One other call out that I would say is in the editor, you can create a blueprint class. And if we search EQS, there's an EQS testing pawn. If we select that, we can just call it EQS_tests. And then what this does is it basically uses whatever testing data you got. I'm going to move this up and then hit, whoops, end. There we go, end. And then the query template, I can add in my different templates here, and it will produce a test result basically in real time, so you don't have to play your project. And if you're basically trying to troubleshoot why your EQS isn't doing something and you just want to see what the values are that you're getting, you can take this little pawn, move it somewhere, and it'll produce the test data, and you can kind of see where it's going to prefer to go, or what it's going to try to do. And that's a little bit easier for debugging. But yeah, EQS is pretty powerful. Like, you can use it for like cover systems. So imagine you use just navigation data in a regular behavior tree to move the player or the AI pawn around, and then if the player shoots him or there's a non-damage event, you can have that event trigger in the behavior tree to run an EQS, and the EQS will query wherever the pawn is at to find cover locations. And then you just have your pawn move to, like, a cover spot to hide. You can get very interesting emergent behaviors by using the system. But all right, people, this concludes the video topic, but I hope you found some informative value that you can take into your own projects. But as always, thanks for watching, consider subscribing, and we'll see you on the next one.